Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to have a look at the solution that was given in lesson 6, okay, to the assignment that was given in lesson 6 of our indices and logarithm lessons. Okay, so, and indeed, this was the second assignment, okay, of lesson 6. So what were we asked to do? We were asked to, this is the question, solve the simultaneous equations, okay, this equation and that equation. So you are given log equations, two log equations for that matter, and you are asked to solve for x and y, basically. Okay, so like our advice, immediately you extract your first log equation or your first equation, you label it. The second equation, you do same. Okay, however, each equation not in the basic form of equation that we solve simultaneously. So what do? We are going to transform. Okay, but okay, if you are smart, you could have dealt with it in a way directly without what transforming. Okay, but let me deal with it from your comfort zone. Okay, so at this point, what are we? Are going to go for it in one direction. After that, we'll look at it from another perspective. And let's see whether we end up getting the same result. So from one, okay, we know our main aim is to switch from log to what? Exponential. So if you want to switch from log to exponential, your log equation that you are given, okay, make sure the log term is isolated. And thankfully, the question has done that part. Then the other log terms, okay, write it as a single log. And in order to write it as a single log, check whether the bases are the same. Yes, it is, okay, it is highly possible for you to write it in what? In a single log, as a single log. Then what do you check whether the coefficient is plus 1 or minus 1? So here, oh, obviously, we have to bring this one up. And that gave us 1. This one was also 2. We have to bring it up. So that gave us log to the base 3 of x squared minus log to the base 3 of y cubed. But this must go up. This must go from where it came from. It was an exponent, that's why it became coefficient. So you take it back. So now coefficient plus 1 minus 1. So you can comfortably write this as a single log. So you write log to the base 3, the base of all the log terms 3. So your single log is supposed to have the same log base 3. Then, because you have negative log term and positive, come and rule your bar. Okay, your numerator term, in your numerator will be occupied by the log, okay, term, okay, the number with a positive coefficient, the number that you are taking log of. So that will occupy the numerator. And the denominator will be, okay, will come from the log term with the negative coefficient, the number that you are taking log of. So that gives us the y cube in the denominator. So at this point, you can switch comfortably from log, okay, exponential. So that will give us this is equal to 3 to the power 7, or 3 to the power 7 is equal to this. However, remember I told you before you label your equation, make sure you clear all fractions if possible. Remove all brackets, okay, if necessary, okay, or reduce if necessary or possible. So in this case, if you clear, you cross multiply, so that will give us this. Okay, and you always have to write the constant first, followed by the variable. So not y cubed and 3 to the power 7. So it will be 3 to the power 7, which is a constant. And because it will give me a huge number, that's why I didn't write it. Other than that, if it was 3 squared, okay, 3 cubed, you could have, okay, write, okay, or should you could have written that as what do you call it? Either 9 or 27. So you take note. Then at this point, you go and take the second equation, then you transform it in the same manner. Okay, so already this is isolated and our log term is isolated. So it means you write this as a single log, then you switch to exponential. So what do we do? This as a single log. Coefficient here is positive. So positive 1. Not, so this one must go up. So that's how come you maintain this. This one goes up. This as a single log again. You have log to the base 3. Your division bar will come. Okay, because you have a positive and a negative log term. So you have a numerator and denominator. The numerator will be this number just for the simple reason I gave up there. Okay, denominator will be occupied by this number, okay, or this quantity. Then it's equals, you switch again to exponential, and that gives you this. You clear the fraction, then you label. So at this point, you know, okay, you have equation 1a and 2a in the form that you usually want. These two are not exponential. They are neither, what do you call it, log. So the usual form. So here you solve, you know x. So you go and substitute x, okay, into equation 1a. So equation 2a into equation 1a, comma. So wherever you see x in equation 1a, it is this. So x is here. So I put the whole of this in brackets by squared. So I square it. It's equal to, okay, the whole of this, which is here. So you know in these indices, if you are squaring the product of two numbers, and in this case, I have the product of a, sorry, 3 to the power negative 7, sorry, negative 4, 3 to the power negative 4 and y squared. So it's like in indices, if I have a to the power m, b to the power n, or to the power maybe x, okay, I know it's the same as a to the power, I multiply mn, and then b to the power, okay, let me change this one. This is x, so it will be mx. Okay, then b to the power nx. Or in the same way, if I have ab to the power what? M. This is equal to a to the power m, then b to the power m. Okay, so my a is this. It will be this one, okay, squared, which will give me, I'll multiply the exponent, so negative 8. Then y squared, okay, all squared will also give me y to the power 4. And that will be equal to what you have there. So at this point, I don't want to have negative. So I brought the negative down, then cleared, okay, the fraction. And I know that if I'm clearing the fraction, it will be 3 to the power 8, multiplying the whole of this. Since the basis of these two are the same factors, I can write it as one factor. So keep the common base, they are multiplying, so you add the exponent and this. Okay, and okay, you move everything to one side, just as if you are dealing with quadratic equation, take everything to one side, factorize. So you solve by factorization, and you can factor out y cubed. Okay, so if you factor out y cubed, you left with y here, and if you left with 3 to the power 15 here. Okay, and again, you have product of two numbers giving you 0. So it means this, okay, y cubed is equal to 0, or this is equal to 0. Then you come and solve for what? Your y here. So here you take cube root of both sides, okay, which will give you y to be equal to 0. Or from here, you can move from here to here. Because you know if you take this is a special situation. You end up in this one, you move this one to the side. So you get y to be equal to this. So you can see that you have two y values. However, we should always investigate, because there's a log equation, to see whether, okay, all the y values, okay, are permissible and be admitted. So obviously, we don't have log of 0. Okay, so it means your y here cannot be 0. Your y here cannot, so this must be discarded and ignore your conclusion with this. The y can take 3 to the power 15. So once you have, initially you had two values, okay, of y, and you discarded one. So it means you are going to get also one value for x. Because this value for y, which would have produced its corresponding value for x, okay, is discarded. So it means automatically its x value will also be discarded. So you come and you label this as substitute 3 into, okay, the one that x is made a subject, which is, so we are going to get this. Wherever you see y, here it is what? 3 to the power 15. So it will be 3 to the power negative 4, then y squared. My y is 3 to the power 15. The whole of that, that's in bracket square, which you come and deal with the square here. So you get what? 3 to the power negative 4, then times this squared will give you 15 times 2. So that will give you 30 as your new exponent. Again, the bases are the same. So you can keep the common base and add the exponent. So you get 26. So you get, therefore, s equal to 3 to the power 26. And you draw your conclusion. Here, you were just asked to solve, but your conclusion must not be in the set. That is one way. Another way, which will be an alternative, okay, if you look at the two equations, you can see that, okay, you have two distinct log terms, log to the base 3 of x and log to the base 3 of y in each log equation. So it will be convenient for us to represent it because of this log that is not making the equation comfortable. So make a substitution for log to the base 3 of x to be a, and that of log to the base 3 of y to be b. So wherever you see, okay, log to the base 3 of x, it is, okay, a. Log to the base 3 of y, it is b. So in that case, my equation 1 will give me 2a, because now this is a, minus 3b is equal to 7. So you call this one a. Then equation 2, this is now a, minus this is now b, is equal to, so you've taken the question to your comfort zone. Okay, and here, elimination or substitution, the one that you can go for. But remember, I've told you, elimination would be ideal if you can add or subtract, okay, straight away to, okay, eliminate without multiplying any equation by anything. Okay, and substitution would be ideal if you can make one of the variable or letters the subject, okay, without involving fraction. So here, obviously, okay, if you want to eliminate a, you have to multiply this one by 2. If you want to eliminate b, you have to multiply this one by 2, multiply this one by 3. So even with the elimination method, a would be ideal. However, substitution would be best because I can make a the subject without involving a fraction from equation 2. So that's what I did from equation 2. A will be equal to, okay, I'll write the positive first. In the actual fact, so I'll be minus 4 plus 2, minus 4 plus what? 2b. But remember, it's better we write the positive term first, so 2b minus 4. And you call this equation 2b. Okay, then you go and substitute equation 2b into equation 1a. And wherever you see a, it is this, you substitute, okay, you expand, okay, combine like terms, and you end up getting, okay, b to be equal to what? 50. Combine like term and solve for b. So 4b minus 3b will give you b. Move this one to the side to give you 7 plus what? 8, which will give you 15. So now you know b, you go and find your a. So you substitute 3 into the equation that you made a the subject, which is 2b. Then that will give you e to be equal to what? 26. However, you know, a and b came by way of your own introduction, so you cannot conclude with them. So you go and substitute back. This implies that, remember, he said a is what? Log to the base 3 of x. So it means log to the base 3 of x is equal to 26. Okay, and b is what? Log to the base 3 of y. And b is equal to what? 15. So you switch here to exponential. So you end up getting x is equal to 3 to the power 26. Okay, and here y will be equal to 3 to the power 15, which happens to be the two values that we had using the other method. And you comfortably can enjoy your conclusion. Okay, I guess my point is well made and I've addressed all concerns, okay, in this short video. Thank you very much once again for a wonderful class. Okay, God bless us all.